We have some angle of elevation problems. So that one video I uploaded, sound didn't go with, so hopefully this time it'll go much more smoother. But the angle of elevation is really nothing new. It's just an idea that we can have this angle from some figure to another figure. The idea here is that sometimes you have some figures and it's from the top of the one figure to the top of the other figure. And so when we draw our triangle here, to find the green one, let's say this height is 10 and this height is 20. Then we would have to subtract these two to find that this in here would be 10 as well. And so the angle of elevation is this idea that we can go from the top of some figure to the top of another figure, or just classically from the base of a figure to the top of another figure. The angle of elevation is from that starting point, that horizontal line that runs parallel to the ground, wherever you're starting from, to the hypotenuse, to the connection of these two other the 2 points that will create the diagonal. When I think of this, I think of, okay, this is a horizontal. This is the horizontal. I think of this, you can think of this as the ground. I missed an R there. Ground. And then this is the vertical, right? And this, of course, is the height, right? This is some height, this vertical line. And then we're left with our hypotenuse, which is diagonal, of course. Right, so these are the three components that I always think of these triangles in, these three separate components. And so if we look and we have, let's just think about, let's say we have a polar bear. We have a polar bear, and the angle of elevation from the polar bear to the top of his igloo, from the top of the polar bear to the top of the igloo, let's say, is 23 degrees. And the polar bear is 8 feet tall, and the igloo is, let's just say it's 27 feet tall. Then we know that when we subtract these two values, we will find that this height here is 19 feet tall. But what we need to do, we can use this now. We can use our angle of elevation and our opposite side. We could use sine to find the hypotenuse, or we could use tangent to find the distance between them. But either way, that's the idea. Angle of elevation can go from the top, or what we find too is that sometimes when we think of it in tandem with the angle of depression. So here we go. Let's look at an angle of depression. Let's say we have a polar bear, and the polar bear is looking down at a fish. Like the polar bear is standing like right at the edge of the water. All right, polar bear is sitting here. And the polar bear is looking down at a fish at an angle of depression of 17 degrees. The idea here actually behind these two things is they have this sort of symbiotic relationship where the angle of depression is kind of going down here from the horizontal line of sight to the diagonal line that connects the top of the bear to the fish. But there's also this idea is that, okay, well, these are alternating interior angles. So if we look at it from the fish's perspective, the angle of elevation from the fish to the polar bear is actually the same thing as the angle of depression from the polar bear to the fish. And so there's this symbiotic relationship between the angle of depression and the angle of elevation. And that's why I don't really stress too much importance of the angle of elevation, because it's sort of a matter-of-fact thing. It's actually this idea is where angle of elevation is from whatever your starting point is with the smaller figure up to the taller figure. And really that's the idea. And the angle of depression is from the top of the tall figure to the horizontal line of sight, or this hypotenuse, and then you'll notice that these two things are interchangeable. It's just a matter of perspective, which I think is actually the most interesting takeaway of this whole topic. All right, guys, thanks for watching.